Welcome back students. I am Sudipto Karmakar, Assistant Professor of Physics, SVIST. And in today's class we are going to discuss about a question that came in MAKAUT in the year 2023-24 odd semester examination. The question is from quantum mechanics and it says that find the value of the given commutator x cap, p x cap and explain the significance of the result. So we are going to discuss this question in today's class. So let's start. So we know the commutation between any two operators. Suppose a cap and b cap. These two are any two quantum mechanical operators. Okay. So commutation between these two operators will be defined as a cap, b cap. This is the commutation bracket. The definition of the commutator between any two operators is a cap b cap minus b cap a cap. So we need to memorize this expression of commutator bracket. Okay. So we will utilize this formula or this expression in our present case. Okay. So here the two operators are, as you can see from the question, that the two operators are x cap, that is the So our two operators are x cap, this is the position operator, and the second one is px cap. This is our momentum, or more precisely linear momentum operator. Which has an expression that is px cap, that is equals to minus I h cut delta x. So it is the x component of linear momentum operator. So in today's problem we are going to evaluate this commutation bracket. Okay. So how to start? We suppose that psi of x, it is any well behaved quantum mechanical wave function. So psi of x is a well behaved quantum mechanical wave function. So we are going to operate this commutator on this wave function. So how to operate? So first of all I am going to write on the left hand side the commutation of x cap, px cap, and it is going to operate on psi of x. So by the definition of commutator bracket we can expand this x cap, px cap as follows: x cap, px cap minus px cap, x cap, that is going to operate on psi of x. Because we all know that, as I have already mentioned previously, that the commutation bracket between any two operator, that is equals to a cap b cap minus b cap a cap. So I am just using this expression here. Here the role of a cap is played by x cap and the role of b cap is played by px cap. Now we already know that the expression of the x component of linear momentum operator, that is minus I h cut delta x. So I am going to put this expression over here. So within second bracket I am writing and dropping the cap notation x and px cap, that means I minus I h cut delta x. So I am writing it here minus, here we have px cap, so I can write here minus I h cut delta x, and this x cap can also be written as only x. that is going to operate on the wave function psi of x. Clear? Now, it results this total term is going to operate on the wave function psi of x, that is x minus I h cut del del x. It is going to operate on the wave function psi minus this total term minus I h cut del del x. It is going to operate on x as well as the wave function itself. Okay, so I am writing here minus I h cut del del x. Since it is on the left of x, so it will also operate on x and it also operate on psi of x. Okay, so it will operate both on x and psi of x. Okay, so we can write over here minus I h cut. Since it is a constant, I can write anywhere I want. So it is x del psi del x minus, and as you can see that it is minus minus, so it results plus I h cut. It is a constant, and del del x, it is going to act on both of x and psi of x. Okay, so the first term is minus I h cut x del psi of x del x plus I h cut. It is going to operate on x and psi of x on both of them, so I can write it here. First of all, del del x, it is going to act on x keeping psi of x constant. So it is del x keeping psi of x constant plus, in the second term, this partial derivative with respect to x, it is going to act on psi of x keeping x constant. As we have already learned about the normal formulas in differential calculus. Okay, so the first term is minus I h cut x del psi del x plus I h cut. This del x, it goes 1, so this goes 1, so we only have psi of x plus 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 I h cut x del psi del x. Okay, so as you can see, the first term and the third term, these two terms are same but with opposite signs, so they cancels out. As a result, we have I h cut psi of x. Okay, so this is our simplified form of the commutation when it is act on the wave function. So on the left hand side, we have commutation of x cap and px cap, that is acted on, or this commutation bracket is operated on the wave function psi of x. And as a result, after all this mathematics, we have on the right hand side, we have I h cut psi of x. So we can rewrite this line as commutation of x cap comma px cap. When it is act on the wave function, it results I h cut psi of x. Now look carefully on both of the sides. On the both of the sides we have the wave function itself, and equity is also maintained between both of the sides. So by comparing both of the sides, we can conclude that this commutation is equal to I h cut. Comparing both of the sides, we have this commutation is equals to I h cut. So we can conclude that the value of this commutation bracket, it is equals to Ig. So this is our value of the given commutation. Now what about its physical significance? What about its physical significance? The physical significance that if the commutation between any two operators is non-zero, it implies that these two commutators cannot be measured simultaneously. Here, as you can see, the commutation between the x cap operator and px cap operator, that is the commutation between position operator and momentum operator, is non-zero. It is eventually non-zero. So it implies that position and its corresponding conjugate momentum cannot be measured accurately and simultaneously. It cannot be measured accurately and simultaneously for a given state. Okay, which supports Heisenberg's position and momentum uncertainty principle. This supports Heisenberg's position, momentum, uncertainty relation or principle. So it was the complete solution of the given question. I hope it will be helpful for your exam purpose. So see you in the next video. Till then, keep learning. Thank you.